All right, guys, let's get started. Today is Monday, November the 9th. It's an A day. Today is A10 of the quarter. So we are expecting a baby soon, and I'm going to keep repeating this every time we do a video because you guys need to be informed. We're expecting the baby either this week, it's possible, or next week. Okay, and I just want you guys to know that once I do have the baby, I will be out and I will be posting things on Canvas. So make sure that you guys know how to get to our homepage. Okay. And so this is our calendar. It starts off kind of old and works its way down to new stuff. And so I'm going to be adding stuff. Right now I have it updated up until this last Friday, November 6th. And I think I'm going to update it and I'm going to try to put our current week up here and try to put old stuff down. Okay. So right here is where you guys should be able to find this week's assignments right here. Okay. And it's got links. I've got a link for the list of tasks so that if you need to make up the whole day, if you were absent, then click that. If you need just the warm up, if I tell you, hey, you need to make up the warm up, there you go. If you need a video lesson, if you need the Edpuzzle, classwork, and so on. Okay. I want to make a note of some assignments that need to be completed that I'm missing. One of them is the virtual lab that we did. This was supposed to be an easy lab. It really was kind of fun, but I didn't get many of them. And so I need students to go back and do that. If you click on this link here, it'll take you to that lab. And then if you click on the Building the Atom video, actually, Building an Atom virtual lab, if you click on that one, it'll take you to the Canvas assignment. I've got the video here that tells you like how to do the lab. And then I'm gonna have an answer key video that I just made. And so I'll put a link to that right there. And so I just need you guys to watch that answer key and then click that and fill out the form. Turn that in. It's a test grade, easy test grade. So it's only 25 questions. It's not too bad. But I'm missing a lot of these. So please do that. And that'll help you grade a lot. I just plugged in those grades, and so a lot of the grades dropped quite a bit when I plugged those in because, like I said, I didn't have that many turned in. Last week, I gave you guys, actually 2 weeks ago, I gave you guys classwork here on parts of the atom. So make sure that you do that one. This is the form. It's a Google Sheet where you basically fill this in. If you get it correct, it changes color. So if I type 1 there, notice that it turns green. All right, and so fill this out and then answer the questions here as best you can. All right, this last one, if you have trouble with that one, don't worry about it. Just try to fill this out as best as you can and make sure you fill out the table. And then you're going to share it with me. Share, which is the green icon up there. Change link to Garland ISD. Click up here, write EMEN. My name will pop up. Click on me. Send. Just send it to me. All right, that's fine. Or you can turn it in on Canvas. Either way is fine. Okay, and then on last Monday, I gave you guys average atomic mass classwork, and I think we were overwhelmed because we did a lot that day, and so maybe you weren't aware of this. So let me click on that. Here's the classwork, so this is the link to it. Here's the formula for how to do it, and here's an example. This is number 1 from the worksheet. I'm only giving you guys 6 examples, and the first one is done for you, so you just need to do 5 more. Okay, these are a little challenging, but they're not too bad. Okay, so here's the 6 problems, and then we've got a test review after, so please complete that as well. I need these turned in by Friday, okay? Number 1 is done for you, so that's good. Let's look at number 2 and see how to do this one. I'm going to try to explain it, but I can't draw on the... Actually, let me see if I can get this on a PowerPoint. Because if I can get this on a PowerPoint, I can show you guys how to do 1 and 2. So let's copy that. Oh, no. Go away. Edit, copy. Okay, now let's open up a PowerPoint and let's go new slide, paste that sucker in there, present. All right, and I'll show you guys how to do this one. So number 2, you've got a table here of isotopes. You've got percent abundance and mass for each isotope. Here's the isotopes. There's 24, 25, 26. What we're going to do is we're going to multiply that percent abundance by the mass, and we're going to get a number. Then we're going to do the same thing for the next isotope. We're going to get another number. Same thing for the third one. We're going to get another number. What are we going to do with these 3? We're going to add them up. Add those 3 up, and you'll get a larger number, right? And so take that larger number, divide by 100, and you get your answer. Okay, this is magnesium. So if you look on the periodic table and look at the average atomic mass for magnesium, remember magnesium is like this. I think it's element number 12, and it's like 24.308 or something along these lines. So this is what you'll see for the square for magnesium on the periodic table. It's going to be on the left side of the periodic table. This is the average atomic mass number. And so the average between these two that you calculate right here, whatever that is, should be close to this value. That shouldn't be exactly, but it should be close. It should be 24 something. Okay. All right, next one. Same thing. Take the percent abundance, multiply by the mass. You get a number. Percent abundance times mass. You get another number. This one will be smaller. Multiply this by this. Get another number. This one will be smaller as well. Add those up. Those three values. Get a big number. Then divide by 100. And you'll see it should get a number. And this one is silicon. And so silicon, I think, is element 14 maybe? I'm not sure, but the average atomic mass should be 28 point something like that. Okay, and so the average atomic mass that you get here should be close to that value. Okay, and let me give you guys a couple more hints on the last two. Number 6 here. So number 6, they tell you that the percent abundance for silver 107 is 51.83%, and then they tell you that the rest is silver 109. So what you can do is take 100 minus that 51.83%, and you'll get the percent of the silver, because you need 2% and 2 masses. Right now you got the percent there, you got its mass. You don't have a percent here, so you got to do 100 minus the 51.83, and you get that percent, and then you got its mass. Do the same thing that you did in the table. All right, and then we've got some a table to fill out to review, because we'll have a table like this on our test. We're looking at a test probably next week. Probably as soon as I'm out, we'll have a test. Okay. And then we got a test review on the history. So this will kind of be some good practice. Okay. All right. I think that's it for assignments. The only other assignments that I'm noticing missing some are the Edpuzzles. So if you're not doing our daily stuff with the Edpuzzles, you need to go back and do those, especially the warm-ups. The warm-ups will kill your grade. All right, you've got to be doing your warm-ups, because I take an average of every day. Did you do anything that day in class? And so make sure that you're doing those things. And most of these warm-ups are easy. Hell, most of the time we do them together. I mean, you just got to pay a little bit of attention and work on those things. And I'll help you out as much as I can. Make it as easy as I can. Trust me, our class is a lot easier than most chemistry classes at Naaman. All the other chemistry classes are way ahead of us. And so they're just flying through stuff, going really fast. We're going a little slower, and we're kind of going at a pace that we're comfortable with. And I'm cool with that. I'm only going to go as fast as I'm comfortable. I'm not just going to throw stuff at you and just keep moving. So let me know if you're not understanding stuff, and we'll work on it. The average atomic mass stuff, I understand, is a challenge for students. And so let's just get through it, and we'll get on with other stuff. So if that's not making sense, just try to do the problems, try to do them on the test, and then we'll move on. That's not easy for most students. But atomic structure, you guys should be starting to understand a lot of stuff about atomic structure and the history. Okay. All right. So for today, day 10, we're going to have a video. Students are expected to watch the video lesson over electron configuration during class and complete the notes. I'm going to give you the notes through the chat. Students will type their answers in the document. It's going to be a Google document, and then they're going to share the change link to Garland ISD and then share it with me. Okay, and I need these by Wednesday or Friday this week. All right, here's the recent assignments that I've been talking about with the due dates. There's that. And then here's an actual link. So if you want all these links, that way you can just click on the one that you need. Let me know and I'll send this to you. Okay. Okay, so Unit 3, electrons. So here's some guiding questions. How are electrons organized in an atom? They are in shells. So each electron is stuck in a different shell. All right, there's 7 total shells around an atom. And so those electrons are put in those shells. You have to fill the first shell first, and then you go to the second and the third and the fourth and so on. But you work your way out. You build the atom from the inside out as you add electrons to it. Okay. How can we use the periodic table to predict electron structure? Ooh, this is good. So how can you look in the periodic table and determine the electronic structure for an atom? The location of elements on the periodic table actually tell us a lot about the electronic structure. All right, and so that's kind of neat. How can we express the electronic structure of an atom? So that means like the address. Like if we're going to write the address, where are all of its electrons located? What are the energies? What are the shapes of the shells? That kind of thing. And so we're writing the address for these electrons. Where are they located? And so we do that by writing the electron configuration. And that's what I'm going to try to get across for you guys today. Okay, we're at 10 minutes already, and so I'm going to try to talk for only 30 minutes. I'm watching a timer here, and so I'm going to try to just keep it to 30 minutes, and then we'll stop the video, and then whatever else we need to cover, I'll make in our video for Wednesday. All right, because I know these ed puzzles get a little long. Now, I don't have any ed puzzles this week. I just need y'all to complete the notes, okay? And that will be a test grade. Electrons, all right? The last energy level of electrons for an atom is called the valence shell. So look at this atom here. Does everybody see this outermost shell here? That last shell, that is called the valence shell. The outermost shell. And the reason the valence shell is important is because when this atom comes in contact with another atom, or even two other atoms, right? If there's another atom here, these electrons that are furthest out are the ones that are going to interact and cause a chemical reaction. Electrons are going to be transferred between these atoms. And so, or they're going to share them, or they're going to steal electrons from each other. And so they're going to bond with each other when that happens. So this valence shell is very important. It's the only one that's involved in chemical reactions. The rest of the electrons in here on the inner part of the atom do not participate in chemical bonding or reactions. So the valence shell is the outermost shell around the outside of the atom. And so the last electrons you put on your atom are going to be in that valence shell. Okay? And we can use the valence shell to predict a lot of things about the atom, how it's going to behave. All right. The group number on the periodic table tells you how many valence electrons an atom has. Okay? So if it's in group 1, it has 1 valence electron. That's easy. Group 2, it has 2 valence electrons. If it's in group 13, which I like to call group 3, and I'll show you what I mean. I like to call it group 3, but on the periodic table, it'll say 13 at the top. So that's group 3, 3 valence electrons. Group 14, 4 valence electrons. Group 15, 5, 16, 6, 17, 7, and 18, 8. And remember, you can only put 8 electrons in a single shell. So the outermost shell of any atom can only hold 8. Right? The first shell can hold 2. So remember, if we have an atom nucleus there, we have the first shell, it can only hold 2 electrons. Okay, and so we got an electron there, so 2 electrons. The second shell can hold 8, and basically after that, we can say that each shell will hold 8. Okay, a max of 8 electrons. Doesn't have to be full, depends on the element or the atom, but it can hold up to 8. All right, so let's look at our periodic table. This is group 1. It is on the far left of the periodic table, so it includes the elements hydrogen and lithium and sodium and potassium. So that's group 1. Group 2 has magnesium. Actually, this is beryllium. Beryllium, magnesium, strontium, calcium. Calcium, strontium, barium. So that's group 2. All right, so the way that we do this, we say group 1, group 2, group 1, group 2, and then look here, skip a few. So group 1, group 2, skip a few. We go all the way to here. This is 13. So if you look on the periodic table, it'll say 13, but it's group 3 because it's got 3 valence electrons. Here's group 4, 5, 6, 7, and 8. So group 3 has boron. It has aluminum. Group 4 has carbon, one of my favorite elements. It has silicon. Group 5 has nitrogen and phosphorus. Group 6 has, I'm drawing a blank here, boron, carbon, oxygen. That's surprised I forgot that. Oxygen is group 6, and the next one is sulfur. The next one is fluorine, and then this is chlorine, bromine, iodine, Okay. And then the next one is helium, neon, argon, xenon, radon, and I'm getting them out of order, but you get the idea. Those are the noble gases. Okay, so we got group 1 in purple, group 2 in blue, group 3 in purple over here, group 4, 5, 6, 7, 8. And so the group number of the element tells us how many valence electrons. How many electrons are in that outermost shell? And that's important for us to understand. If you look at the periodic table, the group that it's in, the column that it's in, tells us the valence electron shells. Now, these guys do not follow the rules, and generally they can have 2 valence electrons. Okay, so just in general, if you want to guess, a good guess for most of these elements in the middle is 2 valence electrons, but they don't follow the rules like the others. Okay, anything in group 1 will have 1 valence electron. Group 2, 2 valence electrons. All the way through these guys, same thing. They all follow the rules where they have the group number they're in, they have that many valence electrons. These guys in here, not so much. Okay, they don't follow the rules. They're rebels. Okay, so groups 30 through 12 and the elements at the very bottom of the periodic table do not follow these rules. Okay, we're halfway through our video, guys. Lewis dot diagrams. Lewis dot diagrams are used to show the valence or the outermost shells of an atom. All right, and so I'm going to just click here, and then let me show you what I mean. So if we have some element, and it's in group 1, I'm going to write the symbol for the element, and I'm going to put a dot there. So hydrogen would be an example, lithium would be an example, sodium would be an example. Anything in group 1, it's got 1 dot. Group 2, it's going to have 2 dots, and I'm going to put them on the corners. Okay, I'm going to put the electrons on the 4 corners because they actually like to spread out. Those electrons repel each other, so they're not going to be hanging out close to each other unless they have to. They repel each other. They don't like each other. So this would be like magnesium. This will be like calcium. They're going to have 2 electrons in the outer shell. Group 3 will have 3 valence electrons, kind of like boron or aluminum. They're going to have 3 valence electrons. Group 4 will have all 4 points covered. So that's going to be like carbon. Carbon has 4 valence electrons. It's going to be like silicon. He's going to have 4 valence electrons. All right, group 5 will have 5 valence electrons. So all I'm going to do is I'm going to put 4 like that, and then I'm going to pair up one of them. And so I'm going to start pairing them after they're full. So after I have all 4 corners covered, then I can pair them up, but not until I run out of room. Because the idea here is you have to spread these valence electrons out. They do not like to be close to each other. So this is going to be like nitrogen. Oh, nitrogen. 1, 2, 3, 4, 5. Okay, oxygen. Group 6 will have 6 valence electrons, meaning that 2 pairs and 2 singles. So that's going to be like oxygen. 1, 2, 3, 4, 5, 6. Okay, two pairs and 2 singles. Group 7 will have 7 valence electrons, so it'll have 3 pairs and 1 single. So that's going to be like fluorine. Fluorine will have 2 there, 2 there, 2 there, and 1 left. So he's got 7 valence electrons. And then group 8 will have 4 pairs, a total of 8 electrons, and that's going to be like neon. Neon has 10 electrons, and so 8 of those 10 are going to be in the outermost shell. And so what these things that I'm drawing here, these are called Lewis dot diagrams. You draw the symbol for the element, and then you put a dot for each valence electron, but only valence electrons. You do not put the inner shell electrons, only the outermost shell. And again, we can determine the outermost shell number of electrons from the group that it's in the periodic table. Group 1 has 1 valence electron. Group 2 has 2. Group 3 has 3. Group 4 has 4. 5, 6, 7, 8. All right. All right, so let's do some more examples. I think I got 4 examples here. So let's look at hydrogen. Hydrogen is element number 1, which means it has 1 proton, it has 1 electron, and so there is only 1 shell. And so here's the hydrogen nucleus. It has 1 proton, and then it's going to have 1 electron out here. So that's kind of a picture of what that atom would look like. And if I write the Lewis dot diagram for this, I'm going to write the symbol for the element, and I'm going to indicate that there's only 1 valence electron spinning around that atom. And so I'll just put that. Hydrogen with a dot. And where you put the dot really doesn't matter, as long as it's got 1 dot on it. That's fine. All right, hydrogen has atomic number 3. That's 3 protons, 3 electrons. So in the nucleus, he'll have 3 protons hanging out. And then in that first shell, he will have 2 electrons. There's one right there. There's one right there. So that's 2 out of his 3 electrons. He's got 1 left. So he will have another shell called the 2, the second energy level, and he will have this 3rd electron there, right? And so the first shell will have 2 of those electrons. The second shell will have the last one. So that's going to be a total of 3 electrons, right? So he's got a total of 3 electrons, and only one of them is in the outermost shell. Do not count the ones in the middle. Only count the outermost shell. So we're going to write lithium and then 1 dot. So it'll almost be the same as hydrogen. The difference is lithium has an inner shell electrons kind of hidden away, but the outer shell electron is the one that matters. Okay. Carbon. Carbon is atomic number 6. 6 protons, 6 electrons. So let's look at him. So we're going to have a nucleus with 6 protons. We're going to have our first shell with 2 electrons in it. There's 1, there's 2. We're going to have a second shell. We have 6 electrons. We just lost 2, so we got 4 left. And so 4 of them will go in this shell. So 4 electrons will go in that shell. So we're going to put carbon and then 4 dots to show those 4 electrons in the outermost shell. Again, do not worry about the nucleus and do not worry about this inner shell. Only the outermost shell. And then oxygen will have 6 valence electrons because it's atomic number 6. And so he'll have 6 electrons like that. 2 pairs, 2 singles. Okay. How is the periodic table arranged? Each of the rows, or the periods, so we call them periods, but they're rows from left to right, indicates the electron shell number, or what we call the principal energy level. There are 7 principal energy levels on the periodic table. 1 for each row on the periodic table. And as you move out from the nucleus, each shell becomes higher in energy, more unstable. And so it's kind of like what we're saying. The energy level is kind of like so you have the nucleus, and then you've got the first energy level. So that's the first energy level, first principal energy level, first shell. Then you got your second shell, third shell, and it goes all the way to 7. So there's 1 through 7 shells, and it's going to represent the 7 rows on the periodic table. So you've got hydrogen, lithium, sodium, potassium, rubidium, cesium, and so that's level 1, 2, 3, 4, 5, 6. That's 6 of them. 6 of the 7 shells right there, and those elements there. And I'll show you what I mean. So here we go. Let's draw out the energy levels. So this is level 1. There's only 2 elements in this level, hydrogen and helium. And the reason there's only 2 is because the first energy level can only hold 2 electrons. If you have 1 electron, then it's hydrogen. If you have 2 electrons, then it's helium, because it's atomic number 2. This is our second level. Everybody see it? Lithium through neon. 2 of these electrons are in these 2 elements. The remaining 6 are in these elements. So this will be the first electron, the second electron, and then this is 3, 4, 5, 6, 7, 8. Remember how I keep telling you guys that you can hold 8 in the outer shell, in the second shell? That's because 2 here, 8 here. And so I want you guys to realize that when you count the elements on the periodic table, it matches what we're talking about with the electron structure. 2 in the first shell right here, 2 in the first shell here. Everybody see that? And then second shell, 6. Okay? Okay, now when we get to the third shell, it gets a little bit more confusing. Let me clean this up. The third shell is right here. The first part of that can hold 2 electrons. The second part of this, actually, yeah, the second part can hold 6. So that's 6 electrons there. And then actually we're going to count these right here. And so that's another 10. And so the third shell can actually hold 18 electrons. So if you do first shell, 2 electrons total. Second shell, 8 electrons. Third shell, it's actually 18. And the fourth shell, it's 30. It's going to be 18 plus 14, 32 electrons. 32 electrons in that fourth shell. All right, so let's look at the shells again. And we're almost done with our video here. This is level 1. This is level 2 right here. Level 3 is these two and these guys. And actually, level 3 also includes these guys. And they are dropped down one level. And the reason for that is kind of complicated, but that all of these guys that I squared out right here are actually part of the 3rd level. Okay, and then the 4th level would include, let me change colors here, would include these guys, and actually even the ones at the bottom. You guys know how there's 2 extra rows at the bottom of the periodic table here? It would actually include this first one here, which would have lanthanum right there, has uranium right there. So all of those are part of that level. So each row on the periodic table is a certain energy level: 1st, 2nd, 3rd, 4th, 5th, 6th, and 7th. Okay? All right. Electrons are arranged into shells, or principal energy levels around an atom. The space around, or the space available that is around an atom where electrons are held is called an orbital. So it's like a house. It's like a place where they live. It's called an orbital. It's kind of like an orbit, but it's more like a cloud. So these are called orbitals, where electrons live. So when I draw a picture of where so here's my nucleus, right? And then I draw a shell there. That's an orbital, right? And it can hold 2 electrons. All right, so each orbital is a place where 2 electrons can live. Okay, and I like to think of it like a twin bed. Think about having a twin bed, and you've got some younger kids. Let's say they're like 3 or 4. You can probably fit 2 young kids in a twin bed, and they probably will be okay. They'll probably be comfortable, right? Not adults, right? Obviously, adults or teenagers like yourself, you're going to each want your own twin bed, right? But let's say that they're real little, and so you could put 2 children in a single bed, and so orbitals are like beds. They'll hold 2 small children. Okay, there are 4 shapes or sublevels, and they're called S, P, D, and F. Okay, and I'll tell you what these stand for. S stands for sphere. P stands for peanut because it's like a peanut shape. D stands for daisy. And F stands for fancy. So these are our shapes of orbitals, okay? The S shape is a sphere. So what I keep drawing for a shell around an atom, that's an S sublevel, okay? Now a P looks like this. It's like a teardrop shape. So it looks kind of like that. And then it's got another lobe over here. So it almost looks like an infinity symbol. So this is space where electrons hang out, and this is space where electrons hang out. And so electrons are zipping in here. But they stay in this area. And so that's a P. And then the D and the F get more complicated, okay? More complicated shapes. But these are just regions where electrons hang out, okay? And orbitals where 2 electrons hang out. And then there are 4 shapes or sublevels. We call them sublevels: S, P, D, and F. All right, here's what they look like. So notice that the S is a sphere. And actually the first level will hold an S, only S. It's the only shape that is possible in the first shell. So first shell has an S, okay? And the next shape is a P, kind of like a dumbbell or an infinity sign like that. And there's 3 of them, and they're identical, okay? And so in the S, you can hold 2 electrons, and then in each of these regions, you can hold 2 electrons. And so if you count this up, 2 plus 2 plus 2 plus 2 plus 2 plus 2, actually, no, I messed that up. There's 1 electron in each of these, and there's 2 there. So each of these regions can hold 1, and so if you add all these up, you can hold 6. So the first shell can hold 2, the P can hold 6, all right, and then the D can hold 10, and then the F can hold 14, and we'll go over this a little bit more detail. As you work your way down the periodic table, what happens? So the first energy level, you have the S sublevel available. All of the electrons will be in that shape. They'll be S. So the first one's called the 1s, and then you've got 2s all the way down to 7s. And these are just spheres upon spheres where electrons are hanging out, okay? When you get to the second level, you have the S available and the P. So you have the S right there. you have the P right here. So this one is available with the second level. All right, and it can hold 6 electrons. So it can hold the S and the P, which gives us a total of 8 electrons. That's why I keep telling you can hold 8 in the second shell. Now the third shell will hold S, P, and D. So for the third shell, you'll hold these guys, and the S. So all 3 of those shapes are possible. And then the fourth shell, you add the last one, S, P, D, F. All right, so if you look on the first period on the periodic table, you get 2 elements, and they fit in 2 electrons, and they fit in an S orbital. You get to the second shell, you got 2 elements, they fit in the S, but then you have the remaining 6 that go in the P shape. And then the third level, you add the D electrons, and the fourth level, you add the F electrons. So let me go back to a periodic table and discuss this further. So first level is right here. Notice that there's only 2 elements here. Let me change my color here. And we are really close to done here, guys. So my first level is 1. It's called the 1s. And so there's 2 electrons there. So like I keep drawing, there's your nucleus, 1s. You can put 2 electrons in there. All right, so 2 electrons can fit in that 1s. And so hydrogen and helium. Each electron is going to be correlated to an element. First electron is hydrogen. Second electron is helium. Okay. Now, if you get to the second level, notice that there's 2 electrons here. That's the 1s, and it's going to be full. So I'm going to write 1s2. And then over here, I got 6. And so that's going to be called the 2p6. Why is it not called the 1p? Well, because it's on the second energy level, right? So this is the 1s. This is the 2s. These guys right here are the 3s. These guys are the 4s, 5s, 6s, 7s. All right, then let's look over here. 2p, 3p, 4p, 5p, 6p, 7p. Now these are actually elements here. It's just on this table they're not shown, but actually this is our last element we found. Element 118 is our last recently discovered element. Okay, and then these are our D shells right here. Let me show you where the D shells are at. So here's 3D. This is 4D, 5D, and 6D is the last one. All right, and then if you look at the periodic table at the very bottom, which is not shown on this picture, the very bottom, the last 2 rows are the F block elements. Okay, and we'll talk about that in our next video. All right, guys, thank you so much.